are your properties of water notes on page 4 in your lab notebook. So last time you talked about the structure of water and the fact that a water molecule is polar. And we talked about that doesn't mean that it's cold or anything or frozen or anything like that. Polar, when we're talking about the chemistry of water, means that it's more like polar opposites. There is a positively partially positively charged side of the molecule, and then there's a partially negative side of the molecule. And when you look at a water molecule, the little Mickey Mouse, the positively charged side of the molecule are the hydrogen side, where the two Mickey Mouse ears are, and the negatively charged side of the molecule are the oxygen part, and that has to do with the shared electrons between the oxygen and the hydrogen atoms. Now, polarity is super important because that is what causes all of the other properties of water that we're about to talk about. All right, so the second kind of property of water would be surface tension. Surface tension is what allows a paperclip or one of those little water bugs to walk across water. You can float a paperclip if you're ever so carefully and you lay it down. It's kind of this tightness across the surface of the water, and the reason that happens is because of the polarity of water. The water molecules are actually more attracted to themselves than they are to the air around them. So the positive side of one water molecule is attracted to the negative side of another one, and they kind of create this really tight bond, which creates surface tension. Water is also known as the universal solvent because you can dissolve so many different substances in water. For instance, salt or sugar. If, for instance, I put salt into water and stir it up, we know that it dissolves. What actually happens on a molecular level is in salt is created by sodium and chlorine. Na is sodium and it's positively charged ion, and Cl is chlorine and it's negatively charged. And then we have our polar water molecule that has a positive and a negative side. So what happens is the water, the negative oxygen is attracted to the positive sodium part and kind of surrounds it, and the positive hydrogen part of the water molecule is attracted to the negative chlorine part of the salt, and it kind of surrounds it, and that's how it dissolves. Water has a high specific heat. What that means is water can absorb a lot of heat before it changes state from a solid, a liquid, or a gas. That's a good thing, and it's super important because if you think about a pond in the winter, as temperatures start getting colder, the pond will freeze. And if the pond froze immediately, all the fish and other aquatic life wouldn't have any time to adjust to that freezing temperatures, and they would die. Water cools down very slowly, so it kind of gives all of those organisms a chance to adjust and kind of move down to the bottom of the pond where the water likely won't freeze, and they can kind of stay over the winter. The other thing is that your body needs to maintain homeostasis. It needs to maintain that balance of body temperature. So if our body is mostly made of water, so when we walk outside in freezing temperatures, even if we don't have a coat on, we don't automatically freeze. Because our body is made mostly of water, our body has time to adjust to those freezing temperatures and start shivering and doing all of those biological things that your body does to keep you warm and maintain your body temperature. Okay, here we go. So next property of water is cohesion. Co, the stem, means together. So this is what allows water molecules to stick to other water molecules. The positive end of one water molecule will be attracted to the negative end of another one, and therefore forms these little droplets of water that we know. Next we have adhesion. The stem ad means toward or next to. Adhesion is what allows water molecules to stick to other polar molecules. So the positive end of a water molecule would be attracted to the negative end of another substance. This is what allows those little water droplets to either form on things like grass to make dew or on the side of your soda can. Next we have capillary action, which is what this is looking at. Capillary action is actually cohesion and adhesion working together. So cohesion, again, is water sticking to water, and then adhesion is water able to stick to other things. This is what allows your blood, which is mostly composed of water, to be able to flow through your veins, and it's also what allows water to be able to be sucked up through the really tiny roots of a plant in order to get water from the ground. And then lastly, we're going to talk about changing state. Water is the only substance on Earth that's actually able to be in all three states, solid, liquid, and gas. And when we change these physical states, the arrangement of our molecules changes. So a quick recap from chemistry, when you have a solid, as in ice, the molecules are very, very tightly packed together and they just kind of vibrate in place. They move very, very slowly. When you have a liquid, the molecules are moving a little bit faster now, but they're just flowing past each other. And then in a gas, you have lots and lots of energy in those molecules. They're spread out and they're kind of bouncing all over the place like crazy. So when we have these processes that change a water from a solid to a liquid or a liquid to a gas, such as freezing, we're either losing or gaining energy. So freezing, we're taking liquid water and changing it into a solid ice. So those molecules are actually losing energy because we're cooling it down. We're taking away heat. And that's taking the molecules that are in a liquid form that are flowing past each other and slowing them down until they become a solid and they kind of vibrate in place. The opposite of that is melting. If we take solid ice, which those molecules are just kind of vibrating in place, barely moving, and we add heat or they gain energy, that solid ice becomes liquid water. And as the heat is added to the solid ice, those molecules start moving a little bit faster and flowing past each other. So that is your notes on properties of water. Thanks.